Photovoltaics, that's child's play. Here, we use zinc. Consider the following.
Ever tried frying an ant with a magnifying glass? Multiply that by 1,000.
That's hot.
Here at VU, the solar thermal electrolysis process team has been working for the past year to make a solar reactor capable of harnessing the sun's energy into a form we can use. Let's go see how it works. So by applying large amounts of solar energy, we're able to split the zinc oxide into zinc and oxygen. This zinc and oxygen can be used in fuel cells to provide electricity. This electricity can be used for things like vending machines or computers or cameras. The list goes on. The important thing is the byproduct of this reaction gives us zinc oxide again, and the cycle starts all over again. Another renewable source of energy. Let's see what the sun has to say.
The ancient Egyptians had it right, man. I am the center of life. I've been pumping out 824 watts per square meter of energy for free for the past, 6 billion years. And you guys haven't even been using it. It's about time someone started to catch on. And whose idea was it to use this coal guy, anyway? It's dirty, it's smelly, it pollutes, and the whole global warming thing, his fault.
No comment.
How do you get all the sunlight to the reactor? Well, someone's got to direct it, and that's me. I take the sunlight, I direct it into the concentrator, my good old pal, and we have a reaction going. Touchdown power!
Alright, so the sunlight enters the reactor through the aperture, right here. That sunlight then heats up the core, and through that core, it transfers heat to the crucible. And in the crucible, we have our zinc oxide, and with a little bit of electricity, we can split that into zinc and oxygen. It exits through the reactor with a chimney, and the rest of this stuff, it's just insulation. It keeps the reactor nice and toasty.
That's hot.
While keeping the outside nice and cool. So in our reactor, we have to use some high-tech materials like silicon carbide, or alumina, or zirconia.
Why, Will?
Because if we didn't, our reactor would end up something like this. Here we are at our testing facility to show you exactly what would happen if we didn't use these high-tech insulation materials. Behold, the torch of science. There you have it. Without these high-tech materials, our reactor would go up in flames. So now that you know how the reactor works, let's see what the team that worked on the reactor has to say.
Designing the reactor wasn't all easy. You know what coal's made out of, right? Carbon. And we want to get carbon out.
No comment.
So instead of using graphite like the previous reactor, we decided to use silicon carbide.
Since time is money, we wanted to make our reactor as easy to assemble and as quick to assemble as possible, so we could spend more time playing things like frisbee, water polo, spending time running, or sleeping. What used to take hours now only takes minutes.
So we had to have a way to control the reactor because we didn't want the sun to have power over it. We needed to control the power. So what we did was we set up a LabVIEW program that uses sensors and controls and allows us to control the reaction as well as the reactor, which in turn allows us to control the amount of power we can get from the reaction.
By using the solar thermal electrochemical reactor of science, we're able to convert the sun's limitless energy into a useful form.
You're welcome.
Now you know.
Bill Nye the Science Guy.